Constructed wetlands. Our world is continuously growing. In fact, our world is growing at a rate of 1.1% per year, from 1 billion people in 1800 to a whopping 7.6 billion people in 2017. Increased population means more buildings and more toilets, baths, and showers to support their everyday needs. And this means an increased wastewater. Another effect of more people and urbanization, and therefore more buildings, are increased impervious surfaces, meaning that water can no longer infiltrate or soak into the earth like a sponge. This increase in impervious surfaces can result in a 45% increase in surface runoff, with only 15% of precipitation infiltrating into the ground. Increased impervious surfaces, increased stormwater. This increased quantity of stormwater is now carrying a decreased quality due to the other effects of urbanization. What is the solution to these problems? Constructed wetlands. A constructed wetland is a man-made or engineered version of a natural wetland, imitating its natural ecosystem services of water filtration and flood control. The most important components of a constructed wetland, in order to mimic a natural wetland's processes, are its filter bed, comprised of sand and gravel, and its vegetation type. The water then enters through the wetland through an inlet and passes through the vegetation and filter bed before the newly filtered water exits the outlet pipe. Wetland design types differ in the direction of influent flow and the surface through which it is filtered. Natural wetlands only make up 5% of the lower 48 states, but more than 1/3 of threatened and endangered species live only in wetlands. Constructed wetlands can potentially offer a greater number of habitats for these animals. Natural wetlands are some of the most biologically productive natural ecosystems in the world, comparable to tropical rainforests or coral reefs. Both constructed and natural wetlands have proven that they can reduce the frequency and intensity of floods by soaking up and storing a significant amount of floodwater. Wetlands can typically store about 3 acre-feet of water, or 1 million gallons, about 3/4 the size of a football field, covered 1 foot deep in water. Globally, natural wetlands estimate to be valued at $14.9 trillion. That is 25 times larger than the United States' annual military spending. Conagry Bottomland Hardwood Swamp, a natural wetland in South Carolina, removes a quantity of pollutants from the watershed equivalent to that which would be removed by a $5 million treatment plant. Wetlands are often inviting places for various recreational activities and provide educational opportunities to students of all ages. The Harbor Brook Wetland Project is a great example of a constructed wetland. The project consists of floating wetland islands, vertical flow wetlands, and surface flow wetlands. This series of constructed wetlands is capable of holding 770,000 gallons of water when full, which is equivalent to 3.25 Nokomis swimming pools. The water capture per year is the equivalent of 63 Nokomis swimming pools. This reduces runoff by the equivalent of 13.6 water towers per year. Constructed wetlands do have a large capital investment and space requirement. Construction time and maintenance requirements are also limiting factors. However, cost-benefit analyses can argue for constructed wetlands' ability to meet the triple bottom line.